Hello, and I'm glad to be here today with you. Today, I want to talk about DevSecOps and the mainframe and how they come together. And listening to parts of the last presentation, one very important concept is this concept of cultural change and really breaking down the silos and bringing teams together. And when we think about the mainframe, generally it is isolated by itself. Not only are there dev and ops teams, but there are dev and ops teams, and then there are the mainframe teams that are the dev and ops teams. So making sure that we are breaking down those silos, bringing things together, and focusing on that idea that everything does come together, everything does work together, everything needs to deliver together in order to move at the speed business truly requires today. When you look at this chart, you'll see that I'm using a representative of the cloud garage method, helping customers transform with culture at the core. But when we think about that, we think about cloud, and yet on this picture, I have a mainframe. The point of this is to say that it really doesn't matter whether or not you're doing APIs, whether or not you're building iPhone apps, or whether or not you're doing COBOL on the mainframe or assembler on the mainframe, PL1. No matter what, you can use the same processes, practices, and culture across the board. Having everyone work together helps deliver that value much faster, using that same automation, that same concept of working together, automate everything, remove the waste, so that you can have this common set of processes and common set of practices. When we think about that automation, we end up talking about the pipeline. The pipeline is at the core of what we do in order to provide this value and this speed. One of the things that I've worked with my design team on is trying to come up with a representative of the pipeline that isn't just a straight line, because that's not really how it works, or an infinity loop, because it's really not that way either. They're loops within loops. And it's important to recognize that I should be able to do my code and my build, do my initial testing, do my code scanning, look for security vulnerabilities, all of those things, and get that absolute fast feedback before I ever move into a provision and deploy. I also have this concept of provisioning and deploying, and it doesn't matter if it's mainframe or it's distributed. I should be able to provision that system, deploy the application to it, run the tests, and then throw it away. And you can do that no matter what platform you're doing development for. Having these concepts of provision, deploy, and test allow you to have those isolated environments, allow you to have that known environment so that you can actually run that automated test, get that fast feedback. You'll also notice I put release in its own box, separate, because it is going to be important to determine when you want to release into production. And there are kinds of changes that you want to release frequently. You want to push out that web update. You want to update the mobile phone app. Then there are systems that maybe don't need to be updated as frequently, though you need to be able to update them, but you don't have to update them. And it's important to recognize that the frequency of delivery into test environments, making sure I can have this process be efficient, fast, and repeatable is absolutely critical. But then determining when I want to deploy to production is also critical. What's the right time? Is the middle of the day when my systems are the most busy the best time? Or is some off hours time when my systems are less busy? Not saying anything's ever down, but things have less busy times. Maybe that's when I want to do it. Or daily reconciliation. Is that a time I want to make a change right in the middle of reconciling systems? Probably not. or transferring between, there are all sorts of things that you want to think about. What's the right time? This diagram also has these concept of analyze, feedback, approvals that are spread throughout the whole process to make sure that you're getting that feedback, that you're doing the right planning, that you're understanding as you're going along what you should be building, getting that feedback whether or not it's the right thing. Monitor is the one on this picture that I have no good answer for. It really should be done the entire time, but you got to put it on the chart somewhere. And so it's there, that you're monitoring your production environment, but you need to be monitoring those test environments as well with the same tools and the same capability that you're doing in your production environment. You want to make sure you're looking for security vulnerabilities from the very beginning and using the same DevSec principles, the same security by design processes that you use in any other environment, no matter what platform you're building for. And in this chart, I've added a number of products, open source, and capabilities that are available to help you do this transformation. You'll notice GitHub, GitLab, Jenkins, Artifactory, Nexus, all open source tools. And yes, I'm talking the mainframe, but I'm talking open source. Those are tools commonly used in the distributed space. And one of the most important things that we've done with the Z system, IBM Z OS in particular, for the last number of years is open it up. Make sure that instead of having a Z OS tool and then something for everything else, that you can use the exact same development practices and tools where appropriate. And the source code manager is one area where there is no reason, and in fact, there are lots of reasons why it should not be different. You need that modern SCM, that same SCM underneath your distributed code and your Z code so that you can bring it together, so that you can do the collaboration between teams. So you break down that silo and remove that barrier. Having people separated in Z teams and distributed teams and Z tools and distributed tools helps keep those barriers alive. The other thing that's important about this transformation is I've been in IBM 33 years. I've been here working in the industry quite a while. And I'd really like people who are starting in the industry now to understand and appreciate the Z platform and understand and appreciate ZOS. And they're not going to if they have to use tools that were written before I was born. So using modern tools and modern practices and allowing them to do development in a consistent way, allowing them to do development in a way they're used to, allows the organization to get new talent, to drive new interest, to get more people into the platform, and more people wanting to work on these systems. In this environment, I have Z development and test environments, or the WASI Workspaces Sandbox. That's ZDNT, ZOS running in Intel Linux. This allows you to do this real provision deploy kind of concept to Intel hardware, so I can provision a ZOS environment in that same cloud environment that I'm doing everything else in. So I can have my Z system working together with the other development going on in the environment. This concept of provisioning has been around for quite a while, but most recently we've added the sandbox, which allows you to run it in OpenShift environment as a container. And so in your OpenShift environment, distributed app, mainframe sitting side by side, being tested, so you get that fast feedback and you can really understand what's going on. I've also mentioned another tool on this chart that you may not have heard of, and it's the Glossa framework. It's an open source testing framework that has come out of the CICS development team or CICF's development team, depending on how you refer to it. They had been using an internal tool that they had developed and discovered that it was of great value when they talk to clients. And so they've open sourced or developed and worked on it to open source it. So it's now available for anyone and everyone, and it allows you to create tests in a way that are familiar to both sides of the world, distributed and Z. They're kind of like JUnit tests, except grown up. It's looking at not a unit itself, but it's looking at that function, that integration, looking at those next stages of testing. But it's a testing framework. So it allows you to build additional managers to work in your system. It has a set of built-in managers, such as a Selenium manager to hook in your Selenium tests. It has access to ZOS and ZOS resources, so you can kick off those tests and run tests. In this environment, you'll also see modern IDEs. That's one place where I actually do need something that understands my COBOL, PL1, or assembler. I don't need it to be different, so it can be a Eclipse, Eclipse Che, or it can be VS Code, but I need an editor that actually understands my language. But we want to do the same processes and the same practices that we do in any other environment. And so if I think about modern development these days, and I think about the way the process works when I'm in a DevOps culture and I'm doing this collaborative development, I assume the ability to do independent development. I want to be able to do this isolated development on my own branch. I want to be able to do that development in a way that I don't affect anyone else. I can get that flexibility, I can get that fast feedback and move on. And so this picture looks like any other development, but it can also apply in ZOS applications. And drilling in a little bit more, from an IDE standpoint, you want that modern experience, you want that environment. And if I happen to want to use VS Code, that's fine. I can use VS Code. I can have my code sit in that environment and I can access my Z system, I can do my development. I can use Eclipse Che and I can have a browser-based solution. I can deploy a set of containers in the enterprise, allowing the developers to do their development. And today, in this challenging world of COVID, where we're all sitting and working from home, we have additional security challenges to deal with. And for many, the idea that developers sitting at home, cloning their source to their workstation is just a little too much. How can we make that more secure? By providing an Eclipse Che environment, you can provide those containers running within your data center or within your dedicated cloud area. By providing that, you keep all your assets in your controlled space, and your developers are simply accessing it with a browser from their laptop. So you're not extending the security problem. And then, of course, we have the standard Eclipse environment. So you have multiple choices. Whatever's right for your developers, right for you. And when we think about this in an IDE, I have static code rules. I have security rules. When I think about this, I should be doing that for my COBOL as well. And one of the discussions I've been having with lots of people recently is this idea that it really is important that that security by design practice apply to COBOL as well, or PL1 or assembler. When we think about it, traditionally we thought the Z was locked up. It was its own boundary. There was no access to the system. But as we expand out, as we provide more access to mobile devices, et cetera, we need to consider that there's not a firewall all around my Z, even if there is. there are ways to get there. And so we need to secure by design. We need to think about it. And there's been a set of code rules, security scanning rules for COBOL for a long time. And in general, we find that developers haven't been doing some of the things because COBOL made it easy to do it right. But it's still possible. And if newer developers are coming on board, it's important. They may not have the experience of all those years of doing development. It's important to have those static code rules and that scanning and that training to understand that it's just as possible to introduce vulnerabilities in COBOL as you can in other environments. You can have that in VS Code or in Eclipse. And those same kind of things, SQL injection, all of those practices. Now, I know when you think about security training, most of the security training is about web apps, but it still applies in other spaces. And maybe the examples aren't given in COBOL, but the thought process is there. And so for this example, SQL injection, I've provided some COBOL examples to help people think about what is the process, what should I be doing even in that, and all of the practices you need to look at from a security standpoint as well. And as I mentioned already, in the Z space, in ZOS in particular, we have Linux on Z, and that system already provides that containerized support, that cloud native development experience. But when we think about ZOS, we don't necessarily think that way. And it is important to recognize that we are doing everything with the platform to help bring it into that experience. We've enabled the modern tools. We've enabled the cloud native development practices, and we have made the system such that you can do self-service provisioning of ZOS. We have clients doing that, provisioning services within ZOS, provisioning environments. It's perfectly possible. And as we move forward, we'll move toward containers even on ZOS for ZOS applications. Today, that's for Linux on Z or Linux on Z within ZCX. But we'll get there to ZOS containers as well. And so as you think about your development practices, you want to start moving toward this process of allowing this kind of support. When we think about it, we also need to think about this automated testing. Automated testing is actually how you get faster. It's how you deliver with quality at speed. You need to be able to test your applications. And so you need to make sure you're doing that unit testing. You need to make sure you're having developers build those unit tests. And yes, that's a cultural change. That's a way of thinking. You can move all the way to test-driven development. That takes more of a jump, a really good jump, but it's more of a jump. Many people start with this idea of, let's just start with unit testing. Let's add in that unit testing capability, making sure we're testing for security vulnerabilities, as well as making sure we're testing for all those error conditions and all those problems, not just happy path testing. And with ZUnit, I can build that unit test and I can run it as part of the build. I don't have to deploy the program first. I don't need the Kix environment. I don't need DB2. I can run that test after I've done my record and playback, so that I can play it back as many times as I need to. After that, then we want to think about what's the next level of testing. And it's really important to be able to do this testing such that the developer can get that fast feedback. And so we wanted to provide a capability that allowed developers to do this testing. And we created this virtual test platform. It allows you to stub out your middleware. So you can stub out Kix, you can stub out DB2 at the transaction level. This is actually the same backend we use for our ZUnit capability, but this allows you to record a transaction. So I can record that full transaction And then I can run that test so I can get that first level of feedback whether or not the code change I made actually breaks something else. Or when I recompile copybooks, I can make sure that didn't break something. If I'm changing versions of compile, I can test my code simply and easily by just running the playback file, and it will run my transaction for me. It makes it much simpler to build up a set of automation and a set of automated tests faster than I could do in any other way to get that fast feedback. Now, obviously, I still need to do integration testing and testing in the middleware. I need to do that deploy and test after that, but making sure I've gotten this first stage is important. I wanted to make sure I got to some stories of customers because this is important. This is a transformation. It's a cultural change. It's a huge change in the way we work. But when we think about that, how do I do it? And what can I do? And I know numbers of customers I talk to are worried about this transformation because, well, that really is a big change. How do you do this kind of change? The first thing to understand is you're not the first. Many large-scale organizations have moved to these modern pipelines, this modern set of development capability, this cross-platform solution, so that they have a single SCM, they have a single pipeline, and they're getting the real value. They're delivering every week, even in their traditional monolithic ZOS applications. It's perfectly plausible and perfectly reasonable. A monolithic application on Z does not limit your ability to deliver frequently. Having the modern pipeline, having the automated tests is what makes this possible. One of the examples on this chart that I'd like to talk about is this large bank. And one of the reasons they were as successful as they were, as fast as they were, is because they had that DevOps advocacy team, as was described by the prior presenter. They had that team that were helping all the rest of the organization do the transformation. And that team was working with groups, whether or not they were distributed or ZOS. So everyone got that same cultural transformation, that same support. And the Z teams were moved into the exact same pipeline with a different IDE and with the right build capability, but the same pipeline. So everybody was working in the same way. Everybody was doing the unit testing using different tools because I need a Z unit for COBOL, I need a J unit for Java, but allowing them to move. And you'd be surprised. In this particular case, they heard a story like the one I'm telling today about the fact that Git could be used for ZOS. They heard that story in a November 2018 to be exact. In 2019, February, they started a POC. And by September, 9 applications, 9 teams had been moved into this new process. They were using the new pipelines and they built the automated tooling to move the rest. And so in the next 4 months, they've moved 50 more teams to this modern process, this modern pipeline that really allowed them to move quickly. And there are other examples here about teams, organizations doing the transformation, doing the cultural work to bring their teams together, moving to modern tools and modern processes, moving to this solution that brings everyone together and allows them to work consistently. DevSecOps is really a cultural transformation and the tools underneath to support that process. We need to make sure we're including everybody. It's biz, dev, sec, inf ops. It's not just dev and ops, it's everyone that's part of this transformation. I hope this session has been helpful, and I know we're slightly off time, but I think I got it close. So are there questions to answer?
Hi, Rosalind. Thank you for the session. We will wait for the questions. Oh, there are already questions. So the first question is, how does DevSecOps differ from traditional software development?
So the reason sec is added in this particular case is to remind us that security shouldn't be an afterthought. Security shouldn't be that other team that does security. Now, you probably do have a pen testing team and you probably do have some security teams, but security has to be part of the daily process. Developers need training to do security by design. The security code scanning needs to be part of every build that you do. You need that feedback right away to make sure you're not doing something that you shouldn't be doing early on. Waiting to the end, it's so much harder, so much more costly to fix. Making sure you have those things at the very beginning. Scanning your open source code to make sure you're using the right versions, you don't have existing vulnerabilities, keeping them updated, making sure developers aren't pulling open source packages that have vulnerabilities into your code. There are all sorts of those standard security practices that just have to be brought into the development process from the very beginning.
Yeah, so the next question is, mission of security clashes with the management team.
So security is an interesting challenge. And when people think about security and they think about practices, they go, security is in conflict with everything else. But it's not. We have to think about security as our daily job. We can't afford to allow security vulnerabilities to hit our systems. We have to make sure. When we think about the Z system, it is the most secure platform in the world. But it's most secure because you can keep it secure. You can also unsecure it. You can open it up. You can do things in your code to create those security vulnerabilities. Management, CIOs, CISOs in particular understand this challenge. It's very important to senior management. It needs to be important to all of us.
Great. So the next question is, how are we bringing integration testing earlier as it would be testing with stubs?
Yes, so integration testing, in particular in the Z space, when I was talking about WASI Virtual Test Platform, it allows you to do that transaction level testing fully stubbed out without the middleware. And so yes, there are stubs, but I have in many cases these large monolithic applications. And so I want to test to make sure that monolith can perform together. Getting that fast feedback, making sure my code change doesn't break something else. And in full integration testing, at some point in time, you really do want to test everything connected together. Absolutely agree. But if you test your application with a stub and you create that same stub as a test against the other application, then you can test sooner as part of the pipeline. You can get that feedback before you get into the integration test environment, and so that you are more likely to find some of the integration problems earlier. You still have to do integration testing in a non-stubbed environment, but you will find many fewer problems and there'll be less testing you have to do.
Okay, the next question is, if our mainframe teams are new to DevSecOps, what are the first steps that we should start with?
The first thing to think about is give them the same, mostly, security training you're giving everyone else. Don't leave them out. And provide the examples as part of that security training to help them understand how it's applicable to their environment as well. So my example of SQL injection, showing that in ZOS, it's just as important to do those same practices. The other thing I recommend is adding tools, adding your security scanning tools, adding your code rules scanning in the process early on, so they get used to that feedback, so they understand and they can see. You're not unless there's significant vulnerabilities, probably going to go change all the existing code. But you do want to look to see what the vulnerabilities are, and you want to avoid introducing new ones. I do know many organizations that when they added the security scanning in particular, they found absolutely nothing. Code rule scanning, they usually find some amount of things and they have to decide what they want to do.
Okay, the next question is, how are you automating UI testing in the CI/CD pipeline?
UI testing is the one I like the least because it is the most vulnerable to error. Selenium testing is the most common, but if we think about ZOS environment, many applications still have 3270 front ends, even if they're not being used. A 3270 interface actually can be easily tested, and since it's probably changing less often, using a tool like Galasa or Rational Functional Tester or whatever your 3270 testing tool is, if you happen to have TPNS on your system, you could use that. It would give you the opportunity to get that UI testing in. I highly recommend all of your testing be as API based as possible. And you do need UI testing, but you also need users testing. That's the one place I actually recommend that a manual test happen to make sure it's usable. Having some amount of Selenium testing to get that automation, though, is important. Depending on your user interface, it gets added in. They are the most vulnerable to problems, though, so you'll have to keep an eye on those tests and make sure you are keeping them up to date and not just ignoring the errors.
Okay, so the next question is, what are the key criteria you consider in your organization to decide moving to DevOps or not?
So I think today it's not a question about whether or not you should do DevOps. It's when are you going to. It is a business advantage today, and/or it's just required. You can't move at the speed business requires today unless you break down those silos and you bring in that automation. That automation helps remove errors, helps remove risk, and improves the overall process. You're also not going to find developers much longer who really want to work in a traditional waterfall stance. Actually, I'm not sure you can find any today. So having DevOps, DevSecOps, BizDevSecOps, whatever term it's going to be used, this process of automation using a pipeline, it's not an option, it's required.
Okay, this next question is, what is your strategy to get the API names to fully move into API-driven testing?
Getting to API testing, fully into API testing takes a conscious effort and a set of executive requirements and support to get the time to work on the process. Now, I do know organizations, they're building APIs purely for testing. So they literally are putting an API on parts of their code just for the testing processes. And that is an option, but that's unusual. Usually you're building APIs so they can be used for the business. And so you need to make sure that you're doing that conscious thought about the APIs. And what many people do is they start by working at what are the boundaries between areas that I want to standardize, build up those APIs. We did have a development organization that put an API on everything that their user interface hit in order to make it simpler to test. But that was a long way down their path. It's a process, it's a culture, it's a changing and giving people time to do the work.
Okay, so the last question is, how to automate end-to-end testing in microservice architecture in CI/CD, because end-to-end testing in such architecture is tricky.
Microservices, services, monoliths, they all bring their own challenges to testing, and they are different. They all give you an additional set of considerations on how to deal with. When I'm thinking about a set of microservices, they are providing a set of APIs. So the first thing with microservices that makes it easier is that I can just test at the API level. So I can hit the API to make sure it's providing the request response that I expect. And then I want to be able to do actual end-to-end testing as part of my automated testing. And microservices architecture, having a set of services running to make sure I can get the function I want to. I know a customer quite a long time ago that actually built an automated test. Now they're a supply company. They built a test that said you could order 99 pencils. And what they would do was have this 99 pencil order hit all sorts of different ways of the system. They'd actually run it in production as well. When you ordered 99 pencils, it would do absolutely everything that was part of the process. Everything, other than print the shipping. Well, it actually print the shipping label, but they wouldn't ship and they wouldn't charge the credit card. Everything else happened. So that way they could ensure that the end-to-end process of that function worked. It was an entirely automated test. It could be run in production. It was run in production to test from all sorts of different places in the world in order to test their performance in production as well, to see that it was performing in a reasonable way so they could find bottlenecks and they could find slowness. Many organizations obviously test their microservices in isolation first, but you do need to come up with what is that end-to-end test? What is that end-to-end thing that I make sure they all fit together in an automated way? What is that that smallest possible way of configuring the environment? And then what is the realistic large way? And with microservices, many people are doing chaos engineering, throwing in errors. It depends on the platform you're running on. You have to deal with failure that's going to happen. If you're running on a Z system, you're not worried about the hardware failure in the same way, but there are other software failures you have to deal with. So paying attention and throwing in those errors is also important because things can fail, software does fail. So making sure that you have that system set up so that things will come up and you test that failure in your end-to-end automated testing as well so that your transaction continues to process.
So thank you for the insightful session, Rosalind. We hope to see you at our panel session end of day.